Good evening and welcome to this Retina UK information webinar. This is one of a series of webinars we'll be hosting, and we'll be delivering at least one on a different topic each month. In our first Ask the Expert session, which is this evening, we are really pleased to have with us today Simon Keightley. Simon is a consultant ophthalmic surgeon and also the Director of Examinations for the International Council of Ophthalmology. With more than 35 years in the field, he will be answering your questions this evening. We are also joined today by Kate Arkle, our Research Development Manager. She'll also be answering some of your questions along with Simon. So if you haven't already asked your questions during the registration process, you can either type your question in the Q&A section at the bottom of your screens, and these questions will be asked by the team on your behalf. So please do leave your questions throughout the presentation this evening, and we will answer as many as we possibly can. If we're not able to get to your question this evening, we will be following up your questions over the next couple of weeks. So thank you once again for joining us, and without further ado, I'm delighted to introduce to you Simon and Kate.
Thank you very much, Matt. Before we kick off with questions, Simon, do you want to just start by telling us a little bit more about your career?
Yeah, sure. Hi, everybody. Good evening, and very nice to join you in this webinar, and hope I can answer some of your questions as best as I can. I mean, I am a jobbing ophthalmologist, basically. I've been working in the NHS for the past 30-odd years. But in fact retired from clinical practice about 2 years ago now. So I haven't actually touched a patient for some time, and I miss them very much. But nonetheless, I keep my brain ticking over pretty well by doing exams. I examine my junior colleagues, which actually is very interesting and great fun, and I learn an awful lot about that. I've also done a bit of work for the DVLA, which I still continue to do sometimes on driving and visual impairment. So that might be an interesting one for any questions that come up. But I am very much a clinical ophthalmologist. So academic ophthalmology, especially all the science and the gene stuff, I may well pass right over to Kate. And hopefully she can help me out. As a trustee of Retina UK, we are blessed really with the medical advisory board headed up by Tara Moore from Belfast, and she is a huge asset to us trustees, and she and her colleagues really do help us decide what research that we should get involved with and support. So that's me, and hopefully I can answer some of your questions. So fire away.
Excellent. Thank you very much, Simon. So obviously we've had some questions in before this evening, and I've sort of roughly split those into clinical sort of questions, so questions people might ask about things they can do now, and also then some research questions, which I was going to sort of put after the clinical questions. So everybody who's listening, if you do think of a question, especially if it's a little bit more of a practical question, do pop that in the Q&A box as soon as you can. As Simon says, he has a wealth of knowledge about driving and visual loss because of his work with the DVLA. So if there are any questions about that, he would obviously be very able to answer those for you. But the first question that we had in prior to this evening was actually about registration, so sight loss registration. So the question says, when someone has a sight test and meets the criteria for registration, whether partially or severely sight impaired, is this discussed with them at their medical appointment with their ophthalmologist? This person, I think, is a professional and says, we very often get calls asking how to register. People don't seem to know. Is it standard practice to discuss this? And what should people do, I guess, if it hasn't been discussed?
Yeah, I mean, I was actually quite surprised to get this question, to be honest, actually, because I think certainly in my experience, we always ask people about registration, you know, and I'm slightly disappointed in my colleagues, really, that it hasn't. Some people have slipped through the net. Registration is really important for people who do have a visual impairment, but obviously there has to be clinical guidelines for this. I mean, basically, how you register somebody is you fill in what's called a CVI form, a certificate of visual impairment. And you probably know this, all the audience, but there are two types. There is sight impaired and severely sight impaired, which used to be called partially sighted and blind in the old days, but it's now changed to those two categories. And each of those has a specific clinical criteria to actually be adhered to. If you have really lousy central vision, in other words, you can't actually read the top letter on the standard Snellen chart in the eye clinic, then you are certainly eligible to be registered either sight impaired or severely sight impaired. It's really important to do that for your benefit, really. I mean, I think what normally happens, certainly in my experience, is that if I find a patient who has got a really bad sight impairment, I always say, well, do you think we ought to consider you as for registration? We're not forcing anybody to do anything, and people might find that it's an impediment and don't want it. I mean, I've had several people who say, no, I don't want to do that. But I think on the whole, it is a very useful thing to do. I think quite a lot of clinics are blessed with an ECLO, an eye clinic liaison officer, who picks these people up often before they even see the consultant, and then puts them and suggests that that's what they do. The form has to be filled in by a consultant ophthalmologist. It can't be anybody else. It can't be a healthcare worker. It can't be a junior doctor. It has to be a consultant.
Right.
So I do have to see them at the outset, and I always, and I'm sure most of my colleagues actually register them. And I think for those people out there who are not sure what it involves, what's the advantages? Well, I mean, it is an advantage in a huge way, because I think anybody who's registered gets referred to social services for an assessment at home. And basically, they really assess what you need for everyday help, such as I don't know, cooking and cleaning, keeping in touch with the family, and help with transport. And it can issue you with a blue badge. Obviously, if you're registered, you can't drive a car, but you can give the card to the badge to your family, who can then park in more accessible areas for you. And it also gives you a half-price television license, which I thought was really great, very handy. Slightly ironic, I think, that, but nonetheless, it does give you help, and it gives you help with council tax bills, free public transport, free prescriptions. So I think it is definitely worth doing. And if you don't, and if you feel that you need to be registered and the subject hasn't been broached, please talk to the eye clinic, and they will, I'm sure, certainly put you in the right direction. And even if you're not registered and have a visual handicap, I think it's fair to say, Kate, isn't it, that you can ask for a social services assessment anyway, can't you?
I think you
can.
Matt might know more about that.
Yes, he might, actually.
Than I do, so feel free to butt in, Matt.
Yeah, sure.
Do you want to just comment on that?
Yeah, absolutely. You don't actually have to be registered as sight impaired or severely sight impaired to have an assessment. You can just ask your local sensory team for an assessment.
And the GP would do it as well, I think, actually.
Okay.
Yeah.
We are aware, for any professionals that are listening, we are aware, and I think the sight loss charity sector as a whole is aware, that there are sadly a reasonable proportion of people who don't seem to get offered registration as a default. There are people slipping through the net somehow or other. So if there are professionals listening, I think just be aware that, well, for everybody listening, Retina UK is working really hard. We are aware of the problem, and we're working with our sight loss sector colleagues to address this issue. But if there are any professionals listening, I think the key thing to be aware of is that don't take for granted that this conversation has been had. And if you ask the question, by all means, and assist people in getting back to their ophthalmologist if needed. As Simon says, it needs to be a consultant ophthalmologist. We have had a question in, I think, Simon, that Matt's just sent me, which actually I think fits quite nicely, is what do the numbers mean when you've had a sight test? For example, 660, 2020. Okay.
Yeah, fair enough, actually. I mean, in the UK, we use the metric system, which is 6 over something, rather than the 2020 one, which is American. So I'll concentrate on that. I mean, the standard Snellen chart, which is the sort of the large letters going down to the very small letters at the bottom. The normal person, normal in inverted commas, basically means that the chart is placed 6 meters away from the patient, or 3 meters in a mirror. So it basically doubles the distance. So you're 6 meters away effectively. The normal person should be able to see the second line from the bottom, basically, which is called 6.6. The top letter is the biggest one at the top is 660, which means a normal person should see that letter at 60 meters away. So if you're actually 6 over 60, your visual acuity, you are actually about 10 times worse, if you like, than a normal person. I mean, I hope that makes sense. The standard Snellen charts, which was universal in my day, is now being replaced by logmark charts, which are slightly more complicated. They've got more letters on each row. And often they're computer controlled, and each letter does actually change. So you can't actually memorize the chart, which I know some people have done. So they are changing a little bit, but effectively it's the same thing. And if you're registered severely sight impaired, you should be worse than 3 over 60, which basically means that if you sit at 3 meters from the chart, which is half the normal distance, you can only just see the top letter. If you're worse than that, you're severely sight impaired. And sight impaired is basically if you're between 660, the top letter at 6 meters, and the top letter at 3 meters, then you're sight impaired. I hope that makes sense.
Yes, I think it does. Actually,
I'm sorry. The other thing that we also think to talk about that is not only is it the central visual acuity, it's also the visual field, and obviously which is very relevant to inherited retinal diseases like retinitis pigmentosa, when your field is actually restricted down. So you can actually have a better central vision, yet have a really bad peripheral vision and still be registered as severely sight impaired.
This actually links really beautifully, Simon, into a question that's come in. It's actually to do with driving and peripheral vision. So what are the sight requirements to have a driving license? I've always been frustrated that my visual acuity is really good, but I have limited peripheral vision. Surely a motorcycle helmet will limit peripheral vision in a similar sort of way.
Very good question, which has been used quite a lot in courts and things, actually, which I have been involved with. But so the driving limits, the driving regulations are, it's pretty simple in this country, thank goodness. You have to read a number plate at 20 meters with both eyes open, full stop. And that is the central visual acuity requirements. And that so that basically means you can have one eye and still pass the driving plate test, number plate test. And it equates on the Snellen chart to 6 over 9, which is another line up from the normal, if you see what I mean. So 3 lines down, 3 lines from the bottom at the chart, with one eye is all you need to drive a car. We're talking about a Group 1 car. Lorries and buses are, as you might expect, slightly different, and I'm not going to confuse the issue by going into that, but there are regulations for those HGVs. But car, you need to read the number plate at 20 meters, 25 yards as it was. In addition, you have to have a good visual field, and the visual field is actually defined as 120 degrees on the horizontal, which basically means if you close one eye, you've got about 120 degrees. If it depends on how big your nose is, to be perfectly honest, it's in the way. It's in the way, but it's about 120 degrees on the horizontal, with no significant defects in the central areas as well. So if you've got blind spots in the middle of your vision, then that's bad news. And if you've got less than 120 degrees, that's also bad news. That does give people with early RP, for instance, a reasonable chance of driving. But obviously, as the field encroaches on the centre, then sadly that actually is reduced. Crash helmets. I'm a motorcyclist actually, so I wear a crash helmet. It gives you quite a lot more than 120 degrees, to be honest. Okay. 120 degrees is remarkably small. But it always worries me a little that, you know, even with 120 degrees, you're going to miss something on the periphery, like a child rushing out to chase a ball and things like that. But it has been well proven, and it's been that standard for quite some time now. Actually, people have challenged it, but it's pretty accurate.
Okay.
I hope that helps everybody.
Yeah, I think that's a really comprehensive answer, actually, and it's good to have that analogy with the motorcycle helmet. I've never thought of that, but
yeah,
it's
no, but they're absolutely right.
Personal experience of that, and
yeah, sure.
Moving on to cataracts.
Okay.
So a couple of questions about cataract. So the first one is, would it be appropriate? Well, it is appropriate. So I'll say, are there any potential complications of having one eye operated on for cataracts and one eye delayed? So the latest, this particular person has obviously had one eye operated on, but their consultant's now retiring and they've been waiting a long time for a date for the second eye. Is that a problem?
Yeah, it's difficult, isn't it? Actually, I mean, cataracts. It's the cataract surgery is the commonest operation performed in the world. Isn't that amazing? And the number of cataract operations that are performed outweigh by far the number of other operations performed. It's quite interesting, isn't it? And it's the oldest operation ever described. I think
really?
Yes. Yeah. It's Romans used to do it, and
wow.
It's a really very, very, very old operation. We don't quite do it the Roman way now, and it is actually quite a clever operation, and really was the meat of my whole career. Really, I used to, and I really do miss doing cataract operations. I have to say, it's a lovely, lovely, lovely operation, and I get a lot of thanks from grateful patients, which is great. And RP, sadly, you often do get cataracts. It's quite a common finding. So we do quite a few RP patients. So to answer the question, and just to go on from that, sorry, cataracts, cloudiness of the lens, for those people who don't know. The eye's like a camera. RP affects the film at the back of the camera. Cataracts affect the lens inside the eye. So surgery is to remove the lens and to put a plastic one in its place, which works remarkably well. It takes about 15 minutes to do, and is a hugely successful operation. If you do one eye, which is what the question relates to, really, it depends on the state of the second eye, but usually one is slightly worse than the other often, and that standard is to do the worst eye and then you do the second eye really as soon as you can, provided the first eye goes well. Ideally, a month later it would be great to do that, but in the real world, with the good old NHS being what it is, it's often delayed, and consultants retiring don't help. It is difficult, and certainly when you've had one eye done, and patients always say, "Oh, that's fantastic, doc. When can I have the other one done?" Because they want the second eye done. So having to wait for the second eye to be done must be hugely frustrating for anybody. In addition, it puts the poor old brain out because it's been used to looking through slightly grotty eyes for quite some time before the surgery. And if you have one done, then the other eye doesn't quite know what's going on, and you do feel very unbalanced for quite some time. I mean, it doesn't do you any harm to leave the cataract where it is medically, unless you leave it for many, many years. But I think, on the whole, it's best to do the cataract, the second eye, as soon as you can, after the first one, really. So, and interestingly, now some centres are offering the two eyes to be done simultaneously, or one after the other, on the same operating table.
Okay.
We rather were anxious about that back in the day when I was doing most of my cataract surgery, because of potential infection between the two eyes. If you get an infection, very rare event, but if you get an infection in one, if you've done them both at the same time, you could easily get two eyes being infected, and obviously that's a devastating complication. But some people now are doing it and using different instruments and different drapes and things like that for each eye, but on the same operating table. And it's becoming more popular now. Quite a lot of my colleagues are now doing that, and I can understand why. Because the risks are very small now. I mean, we use very small incisions, and the risks are remarkably small. I mean, I think to answer your question, your questioner's question is, they ought to ring the previous consultant's secretary, say, come on, I need my second eye done. I'm feeling very unbalanced. And I would suggest that they try and, be proactive in getting that done as quickly as they can, basically.
Yeah. Okay. I hope if that person's listening, I really hope you can get that sorted soon. And we had a very quick little follow-up question to your fun facts. Do you know what the Romans used as a replacement lens?
No, they didn't. No, even when I was training, even though it's about 30 odd years ago, we didn't put lenses in. I mean, because the lenses, I won't bore you too much. So intraocular lenses are the most amazing. It's a great story. During the war, fighter pilots when they were shot up, the plastic of their canopy often went into the eye. Okay. And there was a chap called Harold Ridley, who was an eye surgeon from St Thomas's during the war. He actually noticed that the actual plastic that actually got into the eye from the canopy, usually made of perspex, was very inert, and if you left it, nothing happened. Okay. And it was some bright spark of a medical student who was working with Harold Ridley, saying, "Well, look, why don't you put a plastic, fashioned it into a lens, and use it to replace the lens that you take out with color?" Okay. Isn't that clever? Yeah. And so that was born, and the first one was put in 1949, I think, actually. It's been going ever since. But the Romans didn't do that, and neither did I when I was training. So it wasn't quite 1949, but we weren't doing very many of them.
So you'd have just been taking it out.
Yes, just been taking it out, and you give me very, very, very thick glasses to compensate, which gave you horrendous distortion and things like that. Yeah. Okay. Sorry, that was not quite retina UK material.
No, it's interesting nonetheless. And obviously, as you say, Simon, we do have a significant proportion of our community who are affected by cataracts. So it's always interesting. And actually, our next question is still on cataracts, but obviously from a professional. So we have a client who has Usher syndrome, so that's very much in our wheelhouse, is in her mid-40s and has cataracts in both eyes. Her eye consultant is stating that cataract surgery would not be helpful for her. She has 2 cochlear implants for her hearing loss, which have been very successful, and we think she's unlikely to be resistant to surgery to improve her vision. She has no other health concerns, no glaucoma, no diabetes. What could she do next? Is this a case of the consultant perhaps not explaining their thinking well enough?
I would guess. I do despair sometimes of my colleagues' communication skills. I mean, Usher, as I'm sure people know, is a condition which retinitis pigmentosa is associated with severe deafness. And cataract is certainly a complication of that as well. And obviously this client of yours has fantastic hearing now because of cochlear implants, and that's brilliant. And it seemed logical that, you know, removing the cataracts might actually improve the vision. But I guess the retinitis pigmentosa behind the cataract, if you like, is just become so advanced that removing the cataract is not going to give much in the way of visual improvement. And I guess that's probably what the consultant is actually meaning. I mean, but having said that, it's really very difficult, isn't it? And I must admit, I've actually done quite a lot of cataract operations in people with, for instance, macular degeneration, with really very poor central vision, but quite a significant cataract in addition. But the cataract surgery will let more light into the eye, and therefore, you know, may improve a little bit of navigational vision. So, you know, it may well be that even if they have got a really awful retina, removing the cataract might make a difference. But it's communication, isn't it, Kate? Actually, I mean, you've just got to talk to the patient, basically. And I think I mean that particular patient has to ask the consultant to give a reasonable a reason for that decision and enter into a proper consultation. And of course that patient is always entitled to a second opinion. You know,
absolutely.
We're always entitled to a second opinion. And please don't be afraid to ask for a second opinion. It's really important. And, you know, it's no big deal for the consultant. You know, he will be very happy, I'm sure, to recommend somebody else if that's the case. But you know, unfortunately, that the second opinion may be exactly the same opinion as the first.
Yeah. No, so it's just a matter of encouraging consultants to explain their thinking, and in that case, you know, it might put it to rest. But let's see.
You'd be interested to know that the examination that I run has quite a lot of communication skills stations in it, and one of the exam questions is this exact scenario that there's been.
Oh wow! Okay.
Which is actually very good. So that's terrific.
Ideal. Yeah. Okay. Excellent. So that's all we've got for cataract at the moment. We've got a question here that actually crosses over into neurological disease. So my husband has RP. He was diagnosed with that about 25 years ago. For the past few years, has also had double vision. Last September, he was diagnosed with atypical Parkinsonism, which is, this lady has said, it's like a MSA PSP crossover. Those are two neurological conditions affecting different parts of the brain. And we have been told that the progressive supranuclear palsy part, so the PSP part, is linked to his eyes. Are RP and PSP related, or is it just a coincidence?
Yeah, well, I'm sorry to hear this story. Actually, it must be really very difficult for her, actually, and I sympathise entirely. Actually, it really is very, very tough. I mean, progressive supranuclear palsy, and as you say, as you pointed out, is certainly an atypical Parkinsonian type syndrome. It's just a build-up of certain protein in certain parts of the brain, and basically it gives you it's sort of a Parkinsonian type symptoms like falling over, you know, difficulty with speech, difficulty swallowing, but in addition, it actually affects the eye movements, especially the vertical movements, and patients often do get double vision, which obviously this patient has had for some time, and it's really very difficult to deal with. Interestingly, Dudley Moore, who was one of my heroes, sadly died of PSP. And Linda Romstadt has got it as well, actually, which I didn't know, but it's not uncommon, but very difficult to treat, and I do feel very sorry for people with it. It is undoubtedly related to genetic problems. There's no doubt about that. But as far as I know, it's not associated with RP. The genes involved are actually very different. There is some retinal degeneration involved in PSP, but it's not of the retinitis pigmentosa type. So I think it's purely coincidental, and that's just such bad luck to have two pretty nasty diseases, you know, all in one, really.
And just to clarify, the genetic component of PSP as far as I'm aware, is not a monogenetic situation.
No, it's not.
More
No,
of a, so
no,
it's not going to be
it's not.
passed down through the family
No,
in the
no,
same
that's
way that RP.
a good point. Yes, you're absolutely right. No, it's not.
Yeah.
No,
So,
no.
if you're listening, please don't worry that there are two
Yeah.
heritable conditions going on.
Yes, exactly.
And,
thank you for that. You're right.
Yeah, but certainly it is unrelated. By sheer coincidence, I previously worked for the PSP Association, so I do know a little bit about PSP.
Yeah, yeah.
So yeah, I hope you're getting lots of support if you're listening. There was a question here which I think is a little bit of a crossover between research and the clinical aspects. So how do you see screening for or diagnosis of RP developing in the future?
Yeah, well, that's an interesting one, isn't it? Actually, I mean, as we all know, RP is caused by sort of mutated genes inherited from one or both parents, and mutated genes effectively give the wrong instructions to the photoreceptors. These are the sort of light-sensitive cells in the retina, and the problem is with RP, there's so many different gene mutations exist. You know, I think there's over 60 that have been identified, probably more now, actually, and many more are as yet identified. So it makes it much more difficult to screen for this really, you know, this nasty group of diseases, really. But nonetheless, you know, in my opinion, it's vital that that if RP is suspected, so if you've got a child, for instance, who's having difficulty seeing at night, or visual field reducing, it's really important to get the right diagnosis in as soon as you possibly can, really. So I think the future lies in getting some, you know, more information about the genes involved, getting screening and getting genetic testing for these patients as quickly as we can. And certainly there are quite a lot of increasing ophthalmic genetic centres increasing in the country, who will do the clever gene testing stuff, and genetic counsellors attached to these centres who will then counsel the patient and the families as to, you know, the implications basically for of what is going to happen, really.
Yeah.
So, you know, so I think there is some future. The other thing I would quite like to say about the future of screening is that I think artificial intelligence has got a lot to play in that. I mean, this is a very new, you know, a buzzword that everybody's talking about. You know, it's not just beating grandmasters at chess, but it's also quite a lot of medical stuff can be done by artificial intelligence. And certainly I've had quite a bit of experience in diabetic retinopathy, which is obviously much more common. And all diabetics get their retinas photographed every year, and we are using AI, artificial intelligence, to spot changes in the retina that perhaps human beings who are very fallible can't spot. And I notice, and I'm sure that may well happen for other retinal diseases as well.
Yeah,
I'm sure it is.
Yeah, it's coming our way.
Yeah, and I noticed that some of the there was one application for a research project from Retina UK this time around, is that. But ERGs, electroretinograms, which are, and I'm sure again the listeners will know what an ERG is, but it's basically a recording of the retinal impulse if you flash a light at somebody's eye, basically. And people with retinitis pigmentosa and other inherited retinal diseases do have abnormal ERGs, and AI can be applied, or maybe able to be applied, to these ERG traces, and maybe pick up earlier signs of retinitis pigmentosa, which is really quite exciting. And I think that may well be a goer. Hopefully, will be supported by us.
Yeah, so we just to follow up on that, a researcher that's worked on a project funded by Retina UK, which was a gene hunting project, but at its most simple. So looking for these new genes or new changes in genes that cause RP. this particular researcher was very much at the computer science end of that project, and has now received a large grant from the NIHR, which is the research arm of the NHS, to teach AI to try to recognize genetic faults from retinal scan images.
Brilliant.
So, ultimately, the aim, it's some years away from clinical application, obviously, but the ultimate aim is that the AI can look at the image and instantly have a really good stab at what genetic diagnosis that might match up to, which obviously will save a huge amount of time and make everything much more accessible and quick.
Yeah.
So,
fantastic. I mean, it's great news, isn't it? I mean, things are moving on, there's no doubt.
Absolutely. Let's move on to some of these research questions, otherwise it's been great so far, and really good questions.
Yes, I'm sorry. Yes,
really good, interesting.
That's more interesting. I'm now on slightly more dicey ground, I have to say.
That's okay. A lot of the research questions, we had a lot of very similar, very general questions about research, which is absolutely understandable, kind of what's going on, what are the breakthroughs. So I'll just put those to the side for one moment and start with the slightly more specific ones. I'm living with RP, which essentially means my photoreceptor cells are dying, which absolutely does. Why can't we just replace the cells? What are the barriers to producing these cells and transplanting them to replace my dying photoreceptors?
Yeah, wouldn't that be nice to do that, actually? I mean, the trouble is photoreceptors are incredibly complicated things. You know, they're basically a tiny little cell, rods and cones, and various other little things as well, which are incredibly clever. You know, they do actually convert the light that we see that comes through the eye, through the cornea, through the lens, into the retina, into electrical impulses. I mean, that's damn clever. I mean, and it's really, really difficult to replicate those. I mean, I think the only way forward, really, for actually reproducing these photoreceptor cells is stem cells, really, or genetics. You know, we'll talk about the various fields that there are, but certainly stem cells might be a way forward, and growing new photoreceptor cells or growing new retinas on scaffolding in the labs, and then implanting it into the retina is probably a way forward. But you probably know more about it than me, Kate.
I think typically the big barrier to this has been seen as the challenge of getting transplanted photoreceptors or transplanted retinal cells to wire themselves in effectively, to reach out and connect with the rest of the architecture of the retina. So obviously, if you just put the cells in, they have got to join up with the rest of the network, if you like, in the retina. And I think that's typically what scientists have seen as the big question mark. There are also other little questions like immune rejection, although the eye is, Simon, you can probably explain better, is fairly protected relatively from the immune system. You do still get a degree of immune response, and researchers believe that transplanted cells put into the back of the eye often do seem to deteriorate within 6 months or so, and that's thought to be due to immune response and the immune system attacking those cells. We are now currently funding a project where a researcher is looking to make cells, photoreceptor cells, derived from stem cells. She's looking to fiddle around with them a bit so that they essentially become invisible to the immune system and could be transplanted into anybody's eye, you know, regardless of where they came from, and would be kind of off the shelf, ready to go. So that's a laboratory project at the moment. That's very far off any clinical application, but that's certainly one potential way of addressing that problem. So I think those are the sort of two barriers. Researchers are starting to have recently found that photoreceptors derived from stem cells will reach out and kind of make a handshake with other neural cells, so could potentially reach out and wire themselves in and connect to the optic nerve. So I don't think that that's an absolute no either. So I think there's definitely potential there, and we would just have to let the technology catch up. We'll come to the other way in which stem cells are being applied in a moment when we talk about more generally about what's going on, because there's another property of stem cells which may also help the retina that doesn't involve them actually replacing photoreceptors, but we'll get to that in a moment.
And it's pretty important to stress, sorry to interrupt, it's important to stress that the front of the eye is much better protected against immunity than the back of the eye. Okay. The back of the eye is nervous system and the front of the eye is not, it's effectively skin derived. So corneal grafting is very, very successful and very rarely rejects. Whereas there's the back of the eye, the retina, is much more difficult to deal with because it's nervous tissue, really.
Okay, I actually didn't know that there was.
Yeah. I've done loads of corneal grafts, and most of them do really, really well. Very, very rarely reject, donor corneas. And that cry for donor corneas, please. Please sign your donor forms.
Yeah, that's every day's a school day.
Yeah.
Somebody's asked a question which actually I've heard before, so I think there are a number of people who've seen this particular news article and have been a little confused by it, so I'm going to ask it now. I saw a news clip where a pill carrying gene therapy could be available for RP by 2024. Do you know anything about this, please? Simon and I have had a little chat about this prior to the session.
And Kate knows that I know absolutely nothing about it. But I've looked it up, but I'll leave it to you, Kate, to explain.
Okay. So I think that the news clip was about a company called Mira GTX. I think there was a BBC news clip, and I think it's possibly also been on television in Northern Ireland or Ireland as well. Mira GTX is a biotechnology company which is developing gene therapies for inherited sight loss conditions, gene therapies to address specific genetic faults. And they have a couple of those in clinical trials already. Gene therapy is never straightforward, but let's say these are more conventional approaches to gene therapy where the healthy gene is packaged up in a harmless virus and injected into the back of the eye so that healthy gene can take over from the damaged gene and start producing healthy protein. And I suppose it's possible that Mira might get to a stage in 2024 where some of those clinical trials are finished. There's no pill involved in those ones. But Mira GTX is at a much, much earlier stage with a technology that they call riboswitch technology. The name doesn't really matter. But this is a technology where there is a pill accompaniment to a gene therapy. Now, we don't actually know what which condition Mira GTX is aiming to treat with this technology. They haven't stated that yet. That's still commercially sensitive. But the idea is that you still deliver the gene therapy packaged in the virus via an injection into the eye or whatever tissue it is you're trying to treat, but that you separately then give people a tablet. And in the tablet, there is a small molecule, a more normal drug, if you like, but that substance can act on the gene, the newly injected gene, to switch it on or off and control how that gene is used. So that is much further off. That's still at the preclinical stage. So that is not being tested in humans at all yet. And in addition, we don't know exactly which eye condition Mira GTX have in mind to try and target with this technology. So whoever asked this question, you are far from the only one to be slightly confused by the news piece. This pill technology will not be available in 2024. I suppose there's a chance it may enter clinical testing in the next couple of years, but that's as far as it's going to go. It'll just be in a small, tiny number of people. Mira GTX are much closer to the finish line, if all goes well, with their gene therapies where there is just an injection into the back of the eye, full stop.
Yeah.
So hopefully that.
Yeah, and I think, being simplistic, I don't think there'll ever be a simple pill that you can take to cure retinitis pigmentosa, whatever happens. It will be a lot of clever and it'll probably will still involve injections into the eye, you know, with all the inherent risks of that. So, you know, it's not as simple as it's perhaps made out to be.
And the other, leading on to the slightly more general questions, this has come from somebody who's got RP caused by the USH2A gene. Now, there are currently no treatments for USH2A mediated retinitis pigmentosa that can change the course of the progression of the sight loss that's involved. The questioner says, are there any gene therapies or stem cell treatments making progress, and when will clinical trials start? Slightly leads us on to the more general questions. Have you got any comments specifically on therapies for USH2A?
Not for USH2A, but I think generically, I think, you know, the gene editing, you know, gene manipulation has definitely the way forward. Really, there's certainly a lot of that going on. I mean, I think basically, you know, we all want to know, you know, the magic pills and the magic stuff to cure these terrible diseases, really. And I think there are three threads, aren't there? Really, one is the gene editing and manipulation that we've touched on. With these clever things called CRISPR, which I can never remember what it stands for, but something with palindromes, but I can't quite remember. You know, viral vectors, which I think is really interesting, and that's taken off with all the COVID vaccinations and things like that. And I think with those sort of pressures on science, that may well be, COVID might actually be a possible advantage, actually, you know, of actually stimulating research into that form of treatment. Plus, and there's stem cells, which we've also touched about, and there's also, which we haven't really mentioned, are the bioelectronic implants, which might, you know, that might be another way forward. I mean, that really is sort of a Star Trek Geordie, if you're a Trekkie, putting on your glasses and actually having your retina stimulated by electrodes. But I think all these, and they have been tried, and they are working from one extent to another. But it's all nothing. It's navigational vision and not much else, really, and certainly not no detailed stuff.
The implants are coming back, actually. I think
there
was a surge of implant technology stuff going on, and it never really got anywhere, and I think it failed at a quite late hurdle. But actually now there's renewed interest, and researchers are working really hard on improving that technology. So I think there's possibly a future again for implants. USH2A, sorry, go on.
Sorry, and that's a plug for the Retina UK conference, isn't it? Because I think
yes, it is, Simon. Thank you very much.
Some very interesting lectures about things like that. So anybody interested, come and join the Retina UK conference.
Actually, that's brilliant, Simon. Thank you. We can just give that a little plug, because we will be discussing actually at both we have a professionals conference and an annual conference for our community in June, the 23rd and 24th, a Friday and a Saturday. Professionals on Friday, community on Saturday. We'll be talking about things like registration, actually, and how they fit in, and but also lots of research content as well. So yes,
with a Q&A.
Yes, so do
which I'm chairing, I'm told.
Or joining online. You can either come along in person in London or join us online. So I'll let Matt perhaps jump in at the end and say a bit about that. But USH2A presents certain problems, because like other genes, for example, the Stargardt's gene is a very big gene and doesn't fit neatly into viruses. So yeah, gene editing is certainly probably going to be important for that, and gene editing is a little bit behind gene replacement in terms of clinical trials and things like that, but there is gene editing. It has reached clinical testing in one particular case, not for USH2A but for something else, and lots of lab research going on gene editing. And there are also now more and more things coming through that are not specific to a particular gene, and I think those approaches are going to be really important as well. Simon, what do you think?
Yeah, oh, absolutely. No, I think it's fantastic. It's really interesting talking to these very clever academics and scientists And I think, you know, we ain't seen nothing yet, actually. I think things are going to happen, you know, exponentially over the next few years, which is good, which is very exciting. You know, hopefully I should be alive to see it.
That actually does, there is a specific question saying over the last few years there's been significant progress in the field of ophthalmology. How close do you think we are realistically to developing a cure? This question said for RP.
Yes,
Let's
it's
say
cures.
an effective treatment, perhaps.
Yes, cures and cures aren't really. It is difficult, but yeah, you know, I think it would be nice to think. You know, I'm 70 now, so in my lifetime, you know, another 20 years, we might see at least some people being visually rehabilitated. It would be great.
Yeah, I mean, I think the challenge is that so many people in our community have been told over and over again.
I know.
There's going to be, you know, it's going to be 10 years and then it's another 10 years.
I know it's another 10 years. I know it is, isn't it? And we don't want to raise false hopes. That would be unfair. We have to admit that it is a very complicated field.
Yeah, and I think they're going to trickle through so that some members of our community are going to be able to access treatments far sooner than others, just depending on what their genetic diagnosis is. Obviously, we've got one treatment on the NHS already. Luxturna.
Luxturna is exciting. Yeah, that's great. Yeah.
So that's a gene replacement therapy, but very few people are eligible for that. Indeed. And so we need everybody to be able to access something eventually, and we just need to keep pushing.
Yeah, so give us your money.
Fishing at our end.
I feel like Bob Geldof.
Fishing at our end. But I mean, there's general questions basically saying, are there any breakthroughs, any general updates? Is there anything we haven't touched on, Simon, that you want to add?
I don't think so. I mean, there are a lot of optical stuff coming up. You know, the clever computerized bio-optic devices that are coming along, and certainly the fact that you can actually you know, digitize all these images and magnify them for people with poor vision. I mean, that is quite exciting, and there's a lot more than just telescopes and magnifying glasses now.
Yeah, there's certainly a lot of assistive tech developing alongside the treatment science. And actually, treatments now, there are a vast number of approaches being explored. I think probably even since I started with Retina UK almost 5 years ago, the number of different approaches to treatment. So you've got gene-based technologies, things like gene replacement, which is like Luxturna, and gene editing, and little molecular patches, RNA treatments, where you just cover up the faulty section of gene. But there are companies now, we have got stem cell treatments or a stem cell treatment in clinical trial. The J-site treatment that some people might have heard of. So this is being trialed in America, but the company is intending to go ahead with a phase 3 trial, which is the last phase of clinical testing before applying for licensing for a product. And those cells are just injected into the vitreous. They're just injected into the jelly of the eyeball, with the rationale being that they are not replacing photoreceptors that have degenerated. They are simply producing substances that are nourishing and supporting the photoreceptors that are still hanging on in there and surviving. So that's an approach that it looks like is better when things haven't progressed too far, but nonetheless is looking reasonably encouraging. And then there's optogenetics as well.
Absolutely.
Which is about giving cells in the back of the eye that don't normally sense light the ability to do that, the instructions, if you like, to do that and get on with it. As Simon said earlier about the implants, that's not, certainly within our current imaginings, is not going to be high acuity, detailed vision, but certainly for somebody with very advanced sight loss, who's perhaps only seeing shadows or has no light perception, it could bring back enough for them to get around more independently. So I could go on, and it's 5 to 8, but there are so many approaches now, and encouragingly many more of them are actually not dependent on a particular genetic diagnosis, which I think can only be a good thing.
Yeah.
So.
Terrific. No, it's really, I'm, you know, I mean, I've only been with Retina UK for a year, and all the comments, certainly in the board meetings, it's actually been really very encouraging, and I'm really delighted to be part of this team now. It's really quite, it's great fun, and we've got some very good people on board who know what they're talking about.
Matt,
including you, Kate.
Matt, are there any questions we've missed? Oh, keratoconus.
Oh.
Is there a direct link between am I saying it right?
Yeah, keratoconus.
Yeah, and RP. Is there a link between the two? And are there any specific risks to my RP if I go ahead with the surgery, corneal graft surgery?
Okay, that's an interesting question. And as far as I know, I don't think there's a link between keratoconus. Keratoconus, by the way, is basically an abnormal cornea. The cornea, instead of being spherical, is conical. So you effectively get quite a high astigmatism, sometimes associated with allergies and perhaps eye rubbing, but nobody has really related to that. But it's a progressive condition. It often is treated by what's called cross-linking, when you shine ultraviolet light onto the cornea, which has had riboflavin drops onto it, which is actually quite interesting. The riboflavin interacts with the ultraviolet light and changes the collagen structure, the structure of the cornea. And that seems to be working quite well, but the ultimate one is a corneal graft. Basically, you take out the old cornea and stick in a new one. And if you've got RP, then it wouldn't make any difference, I don't think, provided your retina is in reasonable working order. It's a bit like taking cataracts out of a patient with advanced RP that we've talked about already. So you can replace the optical system quite easily, but whether the retina will actually accept that is another matter. But I don't think there's a link, as far as I know, between RP and keratoconus. Don't think so.
No. Okay, but no direct risk to the retina of having the actual surgery.
No, not at all. No, not at all.
Okay, great. Matt, is there anything else that we've missed, or do you want to start wrapping up?
I want to keep going. I mean, this has been absolutely fantastic.
Yeah, it's been an hour. I didn't realize it's been an hour. It's been quite fun. I really enjoyed myself.
So, well, there are no more questions that have come through to our Q&A box, and we've had nothing else other than those that we've asked come through via email either. So I think that's brought us to a really nice end to the evening on time. You know what I'm like for timekeeping, particularly if you come to conference, which we'll talk about in a moment as well. So just a huge thank you, Simon, for joining us for this Ask the Expert session this evening, and to Kate as well for your input there. As I say, it's been really enjoyable for me. I've learned a huge amount. And of course, thank you to everyone who's joined us on this webinar this evening as well. So as mentioned at the beginning of the session today, we are planning at least one webinar each month. Over the coming months, we have webinars on low vision services, aids and equipment, how you can get involved with Retina UK with volunteering. And we've got a really exciting session coming up in a few months' time around hair care and styling with a hairstylist to the stars. So details.
That's what I need.
Absolutely, you and me both. Details of these are on our website, and we'll also send them to you shortly as well. So just a reminder that Retina UK is a registered charity. We receive no government funding, and we rely on our wonderful supporters to raise the funds needed to provide vital services and to invest in groundbreaking medical research. So there's a couple of ways, there's a huge number of ways that anybody can get involved with this. So two, just to mention briefly, is secure support from companies, so from your employers, which could make a substantial impact on our research funding. Companies are much more likely to choose to support Retina UK with workplace fundraising if a member of our community or a friend or family member recommends Retina UK. So if you know of any such company that may be interested in hearing from us, please do get in touch with our fundraising team. You can do that via email, fundraising@retinauk.org. And if you feel up to a bit of a challenge, you can join Team Retina UK on the virtual TCS London Marathon, which is taking part in just a couple of months' time on the 23rd of April. So you have 24 hours to complete your marathon, and you can choose to run or walk. You can do it on your own. You can walk with a friend. And you literally have 24 hours in order to do this marathon. So you do it at your own pace and on your own route. And just by simply raising £145, you could actually fund a researcher for 6 hours. So worthy cause there. More information on our website, which is retinauk.org.uk/virtual. So we will be sending out an email over the next couple of days, which has got details of where you can rewatch or listen to tonight's webinar, and details of how you can book onto our other events. So other events, as Kate mentioned earlier, include our conferences, which are coming up on the 23rd and the 24th of June. So we are holding it both physically and online. So if you're able to come and join us in London, it's in Marylebone, fantastic venue. You can hear a huge number of eminent professors who are coming to join us, talking all things through gene therapies, through to bionics and implants, and really, really exciting stuff. And as Ken mentioned, we're also going to be looking at things along the registration process and some of the work that Retina UK are doing to support you within the wider sector. So we have a really, really exciting program coming up. The details of that will be shared with you in the email, which I'll send out shortly. And also they are on our website as well. So final point is we value all feedback, and yours today will help us develop our webinars and services into the future. So please do just take a couple of moments to fill in the feedback form when we send it through to you. So Simon, once again, thank you ever so much for joining us this evening. And Kate, of course, as always, thank you for your support with these webinars. Thank you to everybody who's joined us, and we bid you a very good night. Thank you.
Good night.
Good night, everybody.